processes, which kind of, one second, where is the static coming from? Mr. Sundar, you have to mute. There's a lot of disturbance from your end, please. Yeah, thank you so much. Okay, let's go back to this. Okay, so this is what we are going to discuss, and where MBBR process is ideal. There are some places where we should use, and there are some places where we should avoid, and MBBR is not ideal in certain locations. Where it is good, where it is not so good is what we are going to discuss. So first, let us begin with sewage. We all know what sewage is. Sewage is basically the wastewater that comes from human activities, not industrial process or non-human activities. For example, you might say cooking and restaurant is a residential human activity, but no. Human activity means basically we are talking about cooking to a small extent in a residential setup, washing of clothes in a residential setup again, toilet water, shower water, and hand wash. These are the things that we are talking about. So we call all this put together sewage. If we are looking at only shower water, we call it gray water. If we are looking at only toilet water and kitchen waste water, that is called black water. So why this differentiation of gray and black? You can treat gray water and black water separately and use it for different purposes. From strength point of view, if you see, whenever we talk about sewage, people tend to feel, oh, sewage is something very dirty. Shit is a very dirty word. But please understand, shit comes from every human being. If shit doesn't come, the person will be dead, simply. When we eat, shit comes out, right? And shit happens to be a very small part of sewage. This is the biggest misnomer. Everybody, including me, before coming into the sewage treatment industry, I used to think basically the human fecal matter is what constitutes to the, that is a major contributor to the sewage. The reality is kitchen wastewater is a major contributor to the sewage in terms of strength. And when we say strength, how do we measure the strength? We call them key pollutants. There are 5 key pollutants. First is physical impurities like food particles. Then floating impurities like oils. It is also called fat, oil, and grease, FOG. That is a normal word used for this. And then dissolved impurities. That means the food that got dissolved in water and suspended, and then dissolved impurities. Apart from dissolved impurities, your microbial impurities. These microbial impurities are primarily virus and bacteria, which are part and parcel of any wastewater. Okay, and sometimes advanced sewage treatment technologies, if you see, they're also talking about ammonical nitrogen, phosphate, removal of ammonia, removal of nitrogen. Please understand, the sewage strength comes from food. If there is no food, if it is only gray water, like toilet water, it does not have much strength. There is nothing much to treat in that. Maybe there is some small quantity of urea to be removed from wastewater. Otherwise, the contamination level is much, much lower. Whereas when kitchen wastewater is added, it becomes high strength wastewater. The wastewater that is coming from commercial kitchens is extremely high in strength. If you look at developed countries like US, they regulate all commercial kitchens. Commercial kitchens means restaurants. Every restaurant must have a local municipal permission. Local municipal permission means something equivalent to our pollution control board. EPA, Environmental Pollution Control Agency, Environment and Pollution Control Agency. This is the regulating agency in US. In National Capital Region, that means Delhi and surrounding areas of Delhi, again, every restaurant must have a properly designed oil skimmer. They call it oil collaser. This oil collaser is a must because oil is contributor number 1 in terms of wastewater strength. And oil is something that bacteria cannot digest easily. So oil has to be removed from any commercial kitchen. When we are talking about a small STP in an apartment, the situation is different. When we are talking about a municipal sewage treatment plant, that would probably have all restaurant wastewater coming and joining. So typically that has much higher oil and grease content. All right. Moving. I'm sorry? Okay, fine. So why we need to treat? We understood what is sewage. So if the water is coming from something like a hospital or hotel, there also it is the origin is human, but certain constituents will be additional. So we don't call it sewage. That is called process wastewater and industrial effluent. If it is coming purely from human wastage in a residential setup, only then it is called sewage, right? This is the key difference. Now let's move forward. We understood what are the major pollutants, that is food, dissolved food, physical impurities like plastic covers, etc., baby diapers, sanitary pads. These are all like shampoo sachet, hair, and then textile lint. When from washing machines, small textile fabrics will come. These are all physical impurities. And then these do not contribute to much strength in wastewater. All right. Now, moving forward, why we need to treat wastewater? What happens if we don't treat wastewater? World Health Organization says every year more than 1 million children in developed countries or developing countries and underdeveloped countries, like countries, third world countries, they call it. From these third world countries, 1 million people, children especially, are dying because of waterborne diseases. Why these waterborne diseases spread during rainy season? Waterborne diseases have the origin in sewage. Now, this is one part. The second part that is not realized by most of us is we are all victims of air pollution. This we know because we can't escape from the pollutants in the air. In the same manner, what we don't realize is we are not escaping from the pollutants in our wastewater, in our groundwater. Now, if you see any lake in city, the lake is full of water even in summer. Where is this water coming into the lakes? It is nothing but sewage from catchment area, apartments, or wastewater from restaurants, etc. All this is going into the lake. From the lake, it is percolating. Part of that water is percolating into the underground channels, joining our borewell water. So our borewell water contains probably untreated sewage, only filtered by Mother Earth. Okay, this is something that we all need to be aware of. And because of this untreated sewage going and joining our borewells, we are indirectly consuming that water for various purposes, including washing of our utensils, clothes, drinking, right? And this is causing long-term unrepairable damage, like the spurt in cancers, kidney diseases. These are all attributed to pollutants in water, groundwater especially. Our governments do not talk about this openly because it is their responsibility. And they are failing in their responsibility miserably to treat the water and allow it to go into the ground. Even where there are STPs in apartments, most of them are not in use. They are there for compliance purpose because government has put a rule saying that you must use STP. People are simply using it, installing it, but not using it. So 70 to 80% of STPs in India are not working at this point of time. This includes major municipal STPs. As a result, what is happening? The untreated sewage is going into the ground, excess water is going into the nearby drain, like our Musi River in Hyderabad. And this Musi River happens to be drinking water source for all the downstream areas. Like, for example, if you take Suryapet drinking water source is Musi River. And this water goes and joins another river, like Krishna. And Krishna happens to be drinking water source for various towns like Vijayawada, Guntur, even Chennai, right? So untreated sewage is like a time bomb. So this is reason number one why we need to treat wastewater. So here we are doing a very small exercise on understanding how to make sewage treatment plants work. Okay, we all hope this will contribute to better sewage treatment. Okay, what is that? Let us move to the next thing. The basics of biological treatment. When we talk about sewage treatment, traditionally all our civilizations, like our ancient civilizations like Harappa, Mohenjo-daro, all these civilizations existed next to a water body. This water body could be a lake or a river. So if you see any major city in the world, I'm not talking about India, in the world, every major city is next to a river, or there is a river in the middle of a major city, because In the ancient times, there was no means of taking water. So people have to live where water is available. A person cannot live without water. So the population has to exist only as close to water body as practically possible. So every major city has a river. Now, how does it work? Whatever wastewater we are generating typically goes into the river. We take water from the river, we give back our used water into the river. Now, what is river doing? River has a natural purification mechanism. That means it is purifying our sewage. How does it work? How does this purification work? Like we discussed, there are three major treatments that happen. The physical treatment, the physical impurities that are there in water get settled down whenever the water velocity is reduced. That means if the water is not flowing fast enough, these physical impurities tend to settle there on riverbed. So as river progresses, the water becomes purer. If you see Hyderabad, Moosi River in Hyderabad is very dirty, but by the time it goes to Suryapet town, the water looks cleaner. At least appearance point of view, it looks cleaner. It might still have a lot of BOD, COD, but it doesn't have suspended solids, right? Then comes the dissolved impurities. What are the dissolved impurities? Dissolved impurities are nothing but organic in nature. That means they come from food. So wherever there is food, a living species will come and try to eat that food. We put a lump of sugar or jaggery on our kitchen platform, immediately ants will come, flies will come. How do they know that there is food? Right? It is survival instinct is the most basic instinct for every living thing. So they are always searching for food. So wherever there is food, a species for which that food is required will come and start consuming it. So in sewage treatment, it is a bacteria and small viruses which come, mostly it is 99% it is bacteria, which come and eat it. They eat it because it is their food. But they eat it and they proliferate, they grow in strength. Like we discussed, the survival instinct, apart from survival instinct, expansion of the species, that means giving birth to another is a objective of every living species. So a bacteria becomes 2, 2 become 4, 4 become 8, 8 becomes 16. So bacteria grows in geometric proportion like that, provided there is sufficient food, provided there is sufficient oxygen. So every living thing requires food and oxygen. So naturally available oxygen from atmospheric air is aiding or helping bacteria grow in a river body. As long as there is food, that means the food that is coming from our sewage is available, these bacteria will proliferate. And when the food is not there, this bacteria simply dies. So we don't have to do anything extra special to treat sewage. Then you might ask, why we have sewage treatment plants? Why not leave the water into rivers? Right. The question here is, how much water, how much sewage these natural bodies can handle? We are generating far too much of sewage beyond the capacity of these rivers to treat. Right. That is why we need external sewage treatment plant. And how does the sewage treatment plant work? It is simply a replica of what happens in any river. Only thing is you are speeding up the process here. You are giving external oxygen. In a river, what happens? The river is shallow in depth, and external oxygen, atmospheric oxygen will go maybe up to 1 meter deep. And then beyond 1 meter deep, there is no oxygen. So bacteria cannot grow there. In a sewage treatment plant, we give air at the bottom of the tank to help oxygen in the aeration tank improve, like a fish pond, right? And grow. So as long as fresh sewage is coming, bacteria has enough food, and we are giving external oxygen, so the treatment takes place. There is no secret, there is no rocket science in biological treatment of sewage. Okay. Now, there are two types of bacteria that grow and eat this organic content in wastewater. One bacteria is called aerobic bacteria. This aerobic bacteria needs atmospheric oxygen to proliferate. In the presence of oxygen, it will generate carbon dioxide and water. It will break down our organic content, the food that we are talking about. Please remember, food means organic. Organic means carbon and hydrogen combination, CH4. All petroleum resources like methane are all fuels which have energy are nothing but carbon and hydrogen molecules. Okay, so as long as this food is available, bacteria will grow. But the condition number one is it requires oxygen apart from food to grow. Also, there is another type of bacteria which does not require external source of oxygen. This will take oxygen from water itself. If you break down water, you have H2O, you have oxygen there also. So, but this bacteria works in a different manner. This produces methane, CH4, right? This CH4 is nothing but methane, part of our LPG gas, and it also produces carbon dioxide. So in villages in the ancient times, we used to have septic tanks. Before sewage treatment plants, septic tank used to be there. Septic tank is nothing but anaerobic treatment of wastewater or sewage. So in the process, you are generating methane. The small disadvantage of this process is methane generates a lot of foul smell, right? This foul smell is something that we all don't like. So anaerobic process is not to be used in residential or domestic setups. All right, moving forward. What are the treatment stages? Why we call them different stages? Because we are treating water for different purposes. Primary. First thing is, let us begin with a primary process. Primary process means we are not doing anything to change the character of water, but we are making it more treatable. Let us say large physical impurities are coming. They could choke your pump in the downstream process. So in preliminary or primary treatment, you are conditioning the water for process. You are actually not doing anything. All right. So these processes are simply physical, and sometimes chemicals are added to that. In large municipal STPs, we add something like alum, right? In effluent treatment plants, industrial wastewater treatment plants, we use polyelectrolytes. The idea is remove small suspended particles. The larger suspended particles are removed using screens. The screens can be bar screens, drum screens, mechanical screens, any type of screen. And oil is also removed in primary treatment. When it comes to main process, it is called secondary treatment. The secondary treatment is the biological process where you are growing bacteria. It could be aerobic bacteria, it could be anaerobic bacteria, it could be a combination of both. But here we are growing sufficient quantity of bacteria. And then finally comes tertiary treatment, where we are separating the dead bacteria. We are disinfecting just to make sure that leftover bacteria or live bacteria is no longer going into the environment, and remove smaller particles, physical impurities like dead bacteria and sand, etc. This process is done using filtration methods like sand filter, carbon filter, or even membrane filtration. All right. So one small thing that we need to understand here, one small concept is suspended growth versus attached growth. What is the meaning of suspended growth? Suspended growth means bacteria is present in water. Attached growth means bacteria is not present on water, it is attaching to some surface like the walls of the reaction chamber or a process tank, right? Or MBBR media. There are advantages with attached growth. Suspended growth is a slightly older process, whereas attached growth is a more modern process. So moving forward, preliminary treatment or primary treatment, as we discussed, contains grit removal, screening using bar screens, mechanical screens, rotary drum screens. Depending on the volume of or capacity of the STP, we design the kind of primary treatment or screens that we require. FOG stands for fat, oil, and grease. And secondary is basically the biological process. And settling is also secondary process because you are removing dead bacteria and any physical impurities. And finally, tertiary treatment is disinfection using chlorine or sodium hypochlorite or UV lamps, ultraviolet lamps, ozone or chlorine gas, and finally media filtration. When I'm not using the word pressure sand filter here, we could be using simple gravity sand filter also. Gravity sand filter or even a pressure sand filter, activated carbon filter, membrane filtration. These are all part of tertiary treatment. All right, let's go back to the topic that we were discussing one slide before. Suspended growth versus attached growth. What is suspended growth? Suspended growth means simply bacteria is there present in water, right? It is not attached to any surface. But what are the disadvantages of this? when the water is flowing, bacteria is basically something that you can't see with our naked eye. It's so small, it just goes out with water. So it's very difficult to retain bacteria in a suspended growth process. It is always going out of your process tanks. That is why in traditional old process, you have sludge recirculation. It is called RAS, return activated sludge. So all the sludge is returned back continuously 24/7 into the aeration tank. Okay, now this is the older process, right? And what is the disadvantage? The disadvantage is you require huge process tanks. The retention time is much longer in the process. And today, space is a premium. A square meter of land in city would cost anything from 50,000 to 1 lakh. So in such places, it's not possible to build huge tanks or spend a lot of money on investment in tank construction. So this is a disadvantage. We want a more efficient process. So the more efficient process is a attached growth. All right. Now, this also has a second disadvantage. It generates a lot of sludge, right? And this sludge is again something that has to be separated and disposed of separately, which is again going to take more space and more equipment. So any suspended growth process, return activated RAS process, extended aeration process. Extended aeration process is one of the oldest process of biological sewage treatment, and that uses this suspended growth process. As a matter of fact, SBR also uses suspended growth process, right? Then what is attached growth? Attached growth is something where you are putting some media. Media means something where bacteria can attach and grow. It can be even a simple stone, pebble, right? In traditional ETPs, if you see, water is made to flow over rocks, large number of rocks. Okay, because rocks are used because there will be gaps between the rocks. Water still flows. If you use sand, the pores are very small and water may not flow through sand. So there are odd shaped rocks used. So there will be always gaps and bacteria will stick onto those rocks and grow. It started with that. Attached growth started with that. From then, somebody thought, let me use some plastic sheet. They started putting plastic sheets into water. But the disadvantage is bacteria is sticking to plastic sheets, but when you are aerating the tank with air from the bottom of the tank, these plastic sheets started coming up. The purpose got defeated. So then scientists thought of a process where a wheel-shaped, a gear-shaped plastic media is provided, right? It is always in water. It is providing more surface area per cubic meter. So on an average, the MBBR media that we talk about provides a surface area of 400 to 500 square meters per cubic meter of volume. So what is the result? We are able to reduce the process tank size. We are able to reduce drastically the aeration tank volume, the capacity, right? So this is a major saving in terms of space as well as construction cost. So if you are just comparing the suspended growth versus attached growth, in suspended growth, it has a large footprint. Attached growth, the footprint is very small. And suspended growth, the water is, along with water, bacteria is going out continuously. So it is not designed to handle shock loads. Whereas attached growth has a lot of bacteria there. So it is designed to handle shock loads. All right. And then sludge production is extremely high in attached growth, whereas sludge production is low in suspended growth. All right. And from management point of view, operation and maintenance point of view, the complexity is not there in this one, attached growth, because there is nothing, no equipment. So there is no complexity. That's the only disadvantage you can say, disadvantage, right? Let's move forward. Why do we need either a batch process or continuous process? Why not have one process, right? It's like this. Why do we have so many cars? Different people have different tastes. Likewise, different processes, different type of institutions where sewage is generated. We are not talking about only homes. A restaurant, for example. A restaurant does not generate wastewater 24/7, right? A hospital does not generate wastewater 24/7. A shopping mall does not generate wastewater 24/7. An office does not generate wastewater all through the day and night. A factory does not produce wastewater 24/7. right? So if I am designing a continuous process there, my process cost would be much higher. So I need some kind of different process where I can treat wastewater when it is available, right? So for this reason, because we have different types of wastewater sources, we have come up with different processes called continuous process or a batch process. Continuous process means the sewage treatment is taking place in 24 hours, 7 days a week, 365 days a year. The plant is never stopped. It is a continuous process. Batch process means whenever you have sufficient volume of sewage to be treated, you start a batch, the batch will end in given duration of time. For example, sequential batch reactor is a process that is popular as a batch process. In a sequential batch reactor, we divide the wastewater into 4 or 3 batches, right? That means in 24 hours, if there are 4 batches, each batch is of 6 hours duration. In 24 hours, if there are only 3 batches, each batch is of 8 hours duration. Also, if I am treating 100 KL and I am processing 4 batches, that means each of my batch is 25 KL in volume. If I am processing only 3 batches, it means each of my batch is 33.33 KL and 8 hours long. So if I am taking a shopping mall, for example, the wastewater generation begins at maybe 9 o'clock or 10 o'clock in the morning. By 10 o'clock in the night, the process is over. Everything is shut down. Night, there is absolutely no wastewater generation. Right. So if I'm providing a storage tank there, if I'm going for MBBR continuous process tank, I need to have a large capacity collection tank because I have to divide this wastewater into 24 hours. If I am generating 100 KL in a shopping mall, my collection tank needs to be at least 75 KL. What I have generated in 12 hours, I should be able to treat in 24 hours, right? Whereas if I go for SBR, my collection tank need not be that big. I am dividing this into 3 batches. 100 KL is divided into 3 batches. Each batch is of 8 hours long, so 33 KL. So the moment 33 KL is available, let us say by 12 o'clock, my first 33 KL is available, my process will kick in. Again, after 5 hours or 6 hours, another 33 KL is available, my next batch will start. Right. This is a more efficient system for fluctuating loads. And also, what should we say? There will be some places where we don't know how much wastewater will be generated in a day. For example, we'll consider a hotel. Depending on the occupancy of the hotel, wastewater is generated. How many guests are going to occupy rooms tomorrow? We don't know. So you can't design a sewage treatment plant with continuous process for a hotel. For such eventualities, you have a process called batch process, and sequential batch reactor is a good example of this batch process. And sometimes we might also need higher quality water. Where you require higher quality water, you have a process called membrane bioreactor, MBR. So now we understood why different processes have come up, whether it is batch process or continuous process or MBR, MBBR or SBR. All right? Okay, fine. Let's move forward. Now, let us go deep dive into what is MBBR, right? MBBR is nothing but bacteria is growing on a biofilm or on a gear-shaped plastic component called MBBR media. Now, the biggest advantage of this process is this media is self-cleaning. That means if the bacteria attachment is very high, this gear is rotating inside water because of the air coming from the bottom, then excess bacteria is simply shed off. It goes back into the water. So this is always remaining in water. So there is never a situation where bacteria is not having oxygen. It is always taking the dissolved oxygen from available wastewater. This is a more efficient system. Just to give an example of MBBR, SBR process tanks, aeration tanks. An MBBR aeration tank would probably have 6 to 8 hours retention. That means if my STP capacity is 100 KL, 8 hours retention means 1/3. That means my aeration tank volume would be 33 KL. In the same manner, if I am looking at SBR process, my aeration tank volume would be 24 hours. That means SBR aeration tank would be 100 KL. If you are just comparing 100 KL SBR versus MBBR, the aeration tank in SBR would be 100 KL volume. The aeration tank in MBBR would be 1/3, that is 33 KL volume. So this saves time and capital cost. And also, sometimes the process is a lot more robust because you don't have anything automated. There is no switch on, switch off. It's a continuous process. So it's very easy to maintain. It does not require super skilled operators. All right. Okay. Now, moving forward, there is a separate settling tank to remove dead bacteria. Please understand, the whole process works on bacteria. So there is plenty of bacteria that is born and dead. Every 2 hours, you can say almost a new batch of bacteria comes. It is born, it dies. It's an ongoing process. So it is essential for us to remove the dead bacteria. In SBR tank, this happens in the same process tank. You aerate the tank, you switch off the blower, the sludge will settle to the bottom. The dead bacteria goes to the bottom. Whereas in a MBBR process, you have a dedicated settling tank, also called as a clarifier. Because you have a dedicated hydraulically designed clarifier, your efficiency, system efficiency is much higher in a MBBR process tank. All right. So in MBBR, the advantage is it's continuous process. It does not require a very skilled operator to run the system, and it produces lesser amount of sludge, and it occupies smaller space. And beyond everything, the electromechanical equipment size will be much smaller. How is it smaller? If I can just give an example, if I am talking about a 100 KL sewage treatment plant, because it is a continuous 24-hour process, my feed pump capacity will be 100 divided by 24. That means roughly 4,150 liters per hour. Whereas in a SBR, I am dividing the 100 KL into 3 batches. Each batch is of 33 or 34 KL. This 33 KL has to be filled in a matter of 1 hour. So my feed pump capacity in SBR is having a capacity of 34 KL per hour. That means it is 7 to Kishore, am I audible? Please confirm.
Now you are audible, sir.
Yeah, okay. Previously, no?
About that MBBR and SBR, just you are about to talk
about. Okay, fine, Kishore. Okay, thanks. Let's move forward. Because there is a power failure at my end, I just suddenly got a doubt whether my Wi-Fi has gone. Okay, thankfully power is restored back to normal. Right. Let's go back. Okay, so the sizing of equipment. So MBBR has smallest capacity requirement. Similarly, when we talk about a blower, air blower, you require same quantity of air, whether you are doing an MBBR process or SBR process, because you have same quantity of BOD to be removed. The difference is in MBBR, your total BOD is removed in a matter of 24 hours. That means if I am talking about a BOD of input BOD of 250 milligrams per liter, that means 250 grams per KL. In 100 KL, it becomes 0.24 into 100, 0.25 into 100. That is 2.5 kgs. No, 25 kgs. So 25 kgs BOD is there, whether it is MBBR or SBR. But in MBBR system, I require air. That means I require 50 kgs of oxygen to come out in 24 hours time. Whereas I require the same 50 kgs of oxygen to come out in 15 hours time in SBR. Where is this 15 hours coming from? In SBR, in 8 hours, aeration time is 5 hours per batch. Since there are 3 batches, 5 into 3 is 15. So in 15 hours, I need to pump the same quantity of air that I am pumping in 24 hours in MBBR process. That means the blower size in SBR is at least 1.5 times that of MBBR. And like we discussed, the capital cost as well as the operating cost is higher for SBR. So MBBR is a preferred choice. All right, let's move forward. But SBR is suitable for certain places where you are having fluctuating loads, where you do not know how much of sewage is being generated on a given day. Let us say a hotel is there. If there is no sewage, your bacteria will die. If the occupancy is only 10% on a festival day in a particular hotel, then the possibility of the bacteria dying is extremely high because you are not giving sufficient quantity. Whereas in SBR, what you do is, because there is no batch, you don't process. Right? This is the advantage of SBR. Now let us look at the process flow. Today our focus is only on MBBR. SBR is we are going to cover very in depth in the next this session, next Saturday. All right. In MBBR process, the water enters into what is called a screen chamber. I am talking about small to mid size, maybe up to 1 mld STPs. Municipal STPs generally do not use MBBR process. The reason being, MBBR is a continuous process. So you need to store water for lean hours. Lean hours means in the night there is no sewage generation. So you have to feed water. So you need to have a huge collection tank. So building collection tanks is not viable for municipal process. You have to build huge capacity collection tanks. That means if you are designing a 1 mld STP or 5 mld STP in a municipal situation, you need to store at least 2 to 2.5 ml, at least 50% of your STP capacity collection tank is required. If you go for SBR tank, there can be 2 SBR tanks, one open at any point of time. The sewage is directly going into the SBR tank. When the batch volume is full, the process will begin. When the process is going on in one tank, the second tank is receiving sewage. So in large municipal STPs, SBR is a preferred choice. Whereas in domestic setup as well as small townships where the flow is less than 1 mld, MBBR is a preferred choice. So let us stick to MBBR discussion today. So the water enters into what is called a screen chamber. Screen means you are basically removing, it is preliminary treatment, preliminary or primary treatment. Screen chamber means it is a place where we are removing large size physical impurities like plastic covers. In large open drains area, you even get wood, green leaves, dry leaves, along with that sand, all these physical impurities. Even in apartments, you will find shampoo sachets coming into sewage, and then baby diapers. People sometimes stuff diapers into toilets, then sanitary pads, condoms. These are the things that come into sewage, and these things go and choke your pumps downstream. So pumps are not designed to handle such large physical impurities. So what we do is we put a screen to remove any large capacity physical impurities. Instead of using one screen, we use multiple screens. We use a coarse screen with about 25 mm gap, and then we use a fine screen with about 5 mm gap. So the idea is larger particles larger than 25 mm are stopped at the core screen, and smaller particles between the size of 25 to 5 mm are held in the second screen. It becomes removal easier. If the capacity, STP capacity is more than 300 KL, it is always advisable to have some type of mechanical equipment to remove whatever we have collected at the screen. The screen, there is no process. You are physically preventing these large capacity impurities to go into your next stage, that is your collection tank, right? So whatever is blocked there has to be removed physically, either by hand, an operator has to remove, or there can be a mechanical means to remove, like mechanical screens or rotary drum screens, right? These are called mechanical screens. Depending on the STP capacity, you design the screens. If it is something between 300 to 500, 600 KL, we can go for rotary drum screens. If the capacity is more than 600, 700 KL, then we can go for mechanical screens, inline mechanical screens. All right. I think that discussion is not going to help us here. So we are not going deep into mechanical screens or the other discussions. So water is entering, the sewage is entering into the screen. The screen is holding the physical, large capacity physical impurities, and then it is going into an oil and grease tank. What is the difference between a chamber and a tank? A chamber is something where water is not stored. A tank is something where water is stored. A chamber is something where water is coming in and going. There is no storage. That means the inlet and outlet are at the same level. All right. Whereas a tank is something where we are storing, so that there could be some gap between the inlet and outlet. So what is the best way to remove oil and grease? We put it into something called oil and grease tank, OGT. What happens in the oil and grease tank? Oil is always lighter than other physical impurities, lighter than water. So oil tends to float. It will float when the velocity is low or when the velocity is zero. When the water is flowing, there is no possibility of anything coming up. So in an oil and grease tank, it is designed hydraulically in such a manner that you reduce the velocity of your incoming water. You distribute it over large surface area to you reduce the velocity. When you reduce the velocity drastically, oil tends to float. The clear water from the lower levels is going back to the next stage. That is called collection tank or equalization tank. The word equalization is basically used because you are getting different type of wastewater, different strengths of wastewater at different times of the day. In the morning time, when you are washing utensils, you are preparing dishes, cooking. At that time, your organic content is higher. When you are washing your clothes, when you are taking bath, you are using detergents, shampoo, or liquid detergent. These have different impurities. These are rich in chemical oxygen demand, right? They are low on biochemical oxygen demand. So these two types of wastewater are mixed thoroughly, and it is called equalization tank for this purpose. So the water is, you are giving uniform strength wastewater for bacteria to digest. You can't tell bacteria, now I'm giving oil rich food, digest now, and you can't say I don't have food now. Okay. So equalization tank purpose is only one thing, to provide a buffer or cushion to feed water into MBBR tank at a uniform rate. So some of you might get a doubt here. You might ask a question. What if I am generating only 30 KL in a 100 KL STP? Any project, any new project, when it is beginning, it is starting with 0. A new apartment complex, first day, only one family moved in. After 15 days, if you see, maybe some 10-20 families have moved in, less than 10%. In 3 months' time, 20% families moved in. That means we are generating only 20% wastewater. How to treat this wastewater at that point of time? In MBBR, what we need to do is, whatever is the available quantity of wastewater, if we are generating only 20 KL in a 100 KL STP also, this 20 KL has to be divided into 24 hours and you have to feed it at uniform rate. That means if I am generating 20 KL initially, my feed rate would be 20 divided by 24, roughly about 750-800 liters per hour, right? And the operator will keep on making this adjustment based on the incoming flows. As the incoming flow increases, that the occupancy increases, the flow rate increases, and at some stage it will reach the peak flow, right? Your MBBR tank is first filled on first day. The tank is always full. Please understand this. Collection or equalization tank is becoming full, becoming empty. In the morning, early hours, if you see at 6 o'clock in the morning, it is almost empty. By 10 o'clock in the morning, if you see, the equalization tank is almost full. Again, by 11 o'clock, 12 o'clock, or 2 o'clock, 3 o'clock, the tank is little empty. Night again, people have come, they used washrooms, they cooked again, they washed some clothes, etc. Some people took showers. 7 o'clock, 8 o'clock in the night, the equalization tank is partially full. Early morning, it is almost empty. Irrespective of what happens in equalization tank, your MBBR tank is filled on day 1. Your settling tank is filled on day 1 or day 2, right? The MBBR tank overflow is going into settling tank. This settling tank overflow is going into collection chlorine contact tank. All right. Equalization tank is something that is becoming empty, getting filled, depending on the inflow of sewage. MBBR tank is something that is filled, emptied, filled. MBBR tank is something that is always filled on day 1. Same logic applies to settling tank. All right. Now, from construction point of view, from problems point of view, from maintenance point of view, Settling tank is the single most important tank where we need to focus on. If I am a designer, all my attention should be on settling tank. It is problem number one in every STP. If the settling tank design is improper, STP will fail. Why is it so? What is the purpose of settling tank? It is supposed to settle out heavier particles or floating impurities by adding a chemical. I am adding a chemical like alum or a polyelectrolyte, or sometimes if the STP capacity is more, a flocculant also. Now, when I am adding that, I need to have a mixing mechanism. If wherever I am adding a chemical between MBBR and settling tank, I need to have something called a flash mixer. I am adding the chemical in the flash mixer to mix chemical as well as this incoming biologically treated sewage thoroughly. And settling tank design would be such that heavier particles will settle down, clear water is flowing out. So from one side water is coming in, from the other side water is going out. The settling tank can be a rectangular tank or can be a circular tank. Typically, circular tanks are more efficient for settling out suspended solids. That is why if you see large municipal STPs, they always have circular clarifiers. A settling tank is also known as a clarifier or a secondary clarifier or secondary settling tank, SST, SC, whatever name you call it. The objective is settling out physical impurities from treated water. All right. But imperative in this is, if you are seeing the flow chart here, from the bottom of the settling tank, we are taking out sludge, right? The sludge has to be separated. Sludge is accumulated in the bottom of the tank. So sludge has to be separated. Where does the sludge go? There are multiple options. The sludge can either directly go to a sludge digester or a sludge holding tank or a sludge dry bed, depending on what we are providing there. Depends on the project condition, site condition. Most apartments today don't have space for open dewatering of sludge. So we need to have a sludge holding tank, further digest the sludge for any biological content, organic content, and then dewater the sludge, take out inert cake without any suspended or physical organic content, and use that inert cake as manure. All right, that is the purpose of settling tank. Now the clear water, the water that is free from BOD, COD is going into a chlorine contact tank. This chlorine contact tank by name uses chlorine. We are adding chlorine for disinfection. We add sodium hypochlorite or chlorine gas. If the STP capacity is large, we add chlorine gas also. Sodium hypochlorite is nothing but chlorine gas dissolved into water. It is easy for application in smaller plants. In large municipal STPs, we use chlorine gas. So that requires dedicated equipment, dedicated safety protocols, because chlorine gas is a highly toxic gas. From there, it goes into tertiary treatment. Up to settling tank, it is called secondary process, biological process. Then chlorine contact tank onwards, we call this tertiary treatment. Actually, this is not part of biological treatment. It is only to further make it suitable for reuse. Let us say we allow the water to go into drains, municipal drains or natural rivers. Up to settling tank is sufficient. You don't require chlorination, you don't require sand filter, carbon filter. But our Pollution Control Board norms may not permit this. So we may have to treat further with chlorination, with pressure sand filter or gravity sand filter. If advanced reuse is planned, like we want to use the water for flushing, then we need to pass it through a membrane filter like ultrafiltration membrane. An activated carbon filter typically removes residual organic content. Sometimes there will be some mild color in water, yellowish color. That color is removed in activated carbon filter. Any trace smell is also there, that is also removed in activated carbon filter. All right. Now I think we need to stop here because our time is over.